Well, it's been a while. The last one I did when it comes to frame modifications was the Ducati I showed on video a little while ago. So this one is a Yamaha Bolt 0K bike, basically brought off the showroom floor to be done. A bloke I know off the old Australian Street Fighter forum, 80s freak, really cool dude, works at a Yamaha dealership, and he asked me if I wanted to give one a 6-degree rake. So in the last Ducati video and a bit of media, you can actually catch up on how I go about things on my jig. I'll probably put a couple of pictures in and you'll see it all jigged up. But basically, I'll just talk you through it. So this is a cast piece welded into a traditional tube headstock. This is actually 3mm wall, quite thick, about I think it's 38. It's an odd size, just under 1.25 inches. This one's standard 25mm, actually no, 32mm, same as the down tubes. Really nice frame. Put it up into the jig and checked it for alignment, and as far as factory stuff goes, it's pretty close. About 4 or 5 millimeters of, let's get that twist like that. Again, it'll be in the pictures, you'll see the string lines. I've said it before and I'll say it again, factory stuff is all out. Just about every bike you ever ride will be out a little bit, and no one can basically tell the difference. They have to be pretty drastic before just about most of us can notice. I have the technology and the OCD. I tend to make them better than factory. I got this one down to under 3mm. I think it was only about 1.5 to 2. But okay, puppy dog, what are you doing? Anyway, the decision was made to split the 6-degree rake. On the Yamaha Bolt, the tank is quite far back because they're a custom looking kind of thing, and they have this down tube here. Now you've got to either take the top back, the bottom out, or a combination of the two. And after looking at it, we decided that the line through here, to get the bend, to allow this to move forwards, this point goes this way and this angle goes from there to there, meaning that without cutting this tube out, which was an option, I could have cut it here, made a new piece, a single bend, and come straight out of this. Wasn't worth it, was not worth it. So what we've actually done is we've split the difference. We took 3mm back on the top and we pulled 3 degrees at the top, and we pulled 3 degrees at the bottom. Now again, in the jig, you'll see that it was welded here. The whole frame was, I'll get a better shot, the whole frame was isolated, and that area there was braced. And the first thing I did was I actually cut this original tube, and I cut it right through here. I came back here and I de-stitched it off the frame and got it out of the way, and that would allow that to come back and that to go forward by just having these two places that I had movement. And then I cut, well, first I welded bracing onto the top turnbuckles that can move, triangulated so the headstock didn't move, and I cut the tube out. And while I had this held, I used pressure and I just pushed it back and it moved pretty easy. So when this was then in position, I had a chain through the neck here, pulling up on my jig with the hydraulics, and the edges, we didn't put much heat into the frame, very little at all. So this elbow here and this edge here are the ones that just needed to get longer. So when I put heat in, I put very little heat in, just enough in this area and up here to allow the hydraulics to yield it. And we just pulled it to yield. Bit of a balancing act on the flame, but it's a two-man operation and it actually works really well. You don't pickle the steel, you never. I've had them come in and I can see that they've just boiled all the goodness out of the steel. The factory stuff might not be chrome moly, but it's definitely not shit. So this is a new bike. They're very well built, to be honest, compared to the 70s bikes I'm used to looking at and some of the earlier stuff that I've been involved in. So to put the puzzle piece all back together, in the photos you'll see the jig, these two top engine mounts and this tank mount were connected by a jig piece that welded braces back onto a couple of mounts that were removable on my jig. Again, it's in the pictures. So that allowed me to have those 3 points in three-dimensional space. So when I took them away, and this piece was already gone, because I did the jig before I took it off, of course, I came back here and I severed the tube to take that piece out altogether. So what that allowed me to do is make this piece from this line forward is actually a billet piece of 4140 high tensile. So chrome moly tube is a high tensile tube. It's 4130. So very much between the two. 4140 is just the classic billet machining high tensile. Now, it's not solid, of course. They are actually the same with the slugs that I put in here, the inserts that I do. They're actually stronger hollow. That's why tube is used and not solid for a lot of manufacturing. So there's actually a formula for diameter to ID that you go to. But because I made it as a billet piece, it allowed me to make a longer section that goes inside of the tube to hold it in the mill and I used my boring bar and I coped that diameter into that billet piece, and then I trimmed it to size because I wanted to keep this as a accessory rib nut of some description. So I've actually got that right back to there. And again, there's a formula by diameter that I work as, and it's to do with how far the insert can move, because if you have it too tight, you just can't get them in. But you don't want them sloppy, so there's no strength in there. But basically here, like that one there, is that long. It's close to 100 millimeters long. So to put the puzzle all back together, again, this is another billet piece. So it's actually inserted again up to that rib nut, and it was hollowed out, and this is a cavity inside of there, so it was in there. And basically, with moving that up in there, pushing that in there, there's, as you can see, there's 1, 2, 3, 4 by 3, so 6, 9, whatever. It's been a long week. Holes that are drilled through the tube so I can do plug welds. I always do them in 3s. I double up on the long ones. I know it's overkill, but then I know there's absolutely no chance that I'm any weaker than the standard. I just find I don't take any chances. Same here, one there, one around there. So pushes up in there. There was a stainless steel one back here. Another hole. I put a peg in there, dropped it in, used a pick down the piece until it hit my stop, and then I know it's in the right place. This is all jigged up, and you basically, I get right down into the center of the plug. You need a very sharp tungsten and a very steady hand, but because this was 3mm thick tube, it's actually pretty deep, and you arc up on the bottom piece, and you need to get it molten before you start to add any filler, because it's very easy to have it stick to the tube but not actually bond to the insert. So I then wash with a bit of filler, and I deliberately leave it low. There's quite a bit of filler that goes in because these holes are actually quarter. They're the size that I do them. That's welded, it's tacked up, and I know that's in position. Then it was just a case of, like the headstock, I fill that full of wet rags, and again, you need a hot weld to get the penetration, but it's about heat input into the tube for problems that occur when you're warping that tube with the weld. And every tube distorts when you weld it. It just comes down to the techniques that you do to mitigate that. So this is actually really quite close to the race, and I actually prefer to leave the race in. If you control the heat properly, and this is a technique that I've been using in the plumbing industry since I was a boy, is we have to silver solder and braze right next to critical equipment that can't be taken out of line, that could be holding pressure on the other side. You don't want to have 800 kPa of something coming at your forehead. So I do it with wet rags. It's actually fairly hot and not a slow pass, and I get a lot less heat input. And so I've just TIG welded that in. These are the butt welds are TIG welded as well, and this one was, because I used a saber saw, actually quite wide, and it was a little bit of a pain to actually, again, I wanted to bond it to the insert, otherwise there's no reason for it to bloody be there. And I burnt that in, and again, all left it down, because one of my trademarks is I like that by the time undercoat goes back on it, there's no way you can see where I've been. So I actually do a TIG brace, and things that I want to bring back to lovely tube, I TIG brace some silicon bronze in. Low temperature doesn't change the properties of anything I'm in, and like you get little tiny bits that really, if I sanded it more, would come out, and an undercoat comes on and it just comes up beautiful. The same reason that I don't use any power tools for the final finishing. All of my work I file finish. I find that file finish is the only way that you can get that tube to look. Power tools generally spin or they run like that, and what it does is it tends to get a wave in the tube and it catches your eye. So again, while this was jigged, this was all bolted back in, welded back onto the frame. It had already had its insert extension in, and then just TIG weld back on there as well. So after all of that, I took my final measurements to make sure I was all perfect, and I was, yes, I believe I was, I'll have to look it up, I think it was under 2 millimeters out of twist in alignment, and we had 6 degrees of rake in it, and I'm really happy with it. The little tiny break we had to put into it there, it just disappears, and it's actually very difficult to see that it's been done, and I'm really kind of stoked with it. So this is just in raw metal at the moment. Again, in a lot of the pictures you'll see a yellowy wax type of product. It's horrible. It's a spray-on rust. It's like when you buy taps and dyes. They come in a waxy paper. It's a chemical that starves the metal of any oxygen, so you don't get any rust. Product's called soft steel. I spray it on because there's periods of time between the work on it, and I don't like the job to rust up. I know it's probably no drama, it's just what I do. It comes off with brake cleaner or any solvent. If you're just going to touch up the bloody frame, it might be a pain in the ass, but like this frame's a full custom build with a full custom paint job. It will be all of our stuff, and people that build these, you have it blasted, and then you have straight for powder coat, or one of my preferred is 2-part epoxy primers that seal, and you can have it sit for forever. The soft steel, if I've got to go back in, I don't have to break the undercoat. So I generally use it, and it can sit for years. It's always virgin metal underneath, so it will just clean off with any type of solvent. Acetone I've just done this one with brake cleaner. So that is a 6-degree rake on a Yamaha bolt frame. I'm kind of happy with that one, and really happy with how my jig's performing. So on that note, it's the day before Christmas Eve. Hope you all have a good season, and hope that 2022 is better than the last 2 we left behind us. Catches.